Good morning, everybody. Everybody's wide awake. Everyone went off and had like a nice romantic dinner with their loved one or something like that. I had a great conversation in New York a little while ago about platform as a service with our next speaker. One of the interesting things about platform as a service is that it allows us to do things very, very well at scale because we let the people who are running the infrastructure worry about how to be efficient. So for the last 50 years, as we've developed higher and higher level programming languages, we've always assumed that as we moved up the stack, we were giving up speed. Assembler was really, really fast. C was pretty fast. Java was slower. And as you moved up and got more abstracted, you gave up efficiencies because you were further from the low-level machine. And that's a perception that I think has infected our thinking about cloud computing because we view it as, well, if I can't get bare metal, I'll get a virtual machine. If I can't get a virtual machine, I'll get a machine image on a cloud. And eventually you're moving up to high-level programming languages that are sort of cut and paste, but you're giving up performance. Peter Magnusson is the Director of Engineering for Google App Engine, and he's going to spend some time talking about why that may not be true. Peter.
All right, hi guys. Let's see how this thing works here. There we go. All right, so my name is Peter Magnusson. I work at Google with cloud computing products. In particular, I work with Google App Engine, Platform as a Service. I'm not going to talk that much today about App Engine in particular. We have a booth here, so happy to talk to anybody here afterwards. But the key thing is that I want to talk about is some of the observations and some of the thinking coming out of looking at running these shared systems at a very large scale. App Engine today, these are some new numbers that I'm sharing today. We're now at 30-day actives of over 500,000 applications running on a single infrastructure. And they together serve up over 200 billion monthly hits of different sorts, all from page views to being backend services. So this is operating at a fairly large scale, which brings to mind some of the things that I talked to Alistair about in New York a little while about that I was going to share today. So, but first I want to talk about Littlest Pet Shop. So Littlest Pet Shop is a $12 billion business. Just messing with you. It's nowhere close to $12 billion. But when I look at the amount of money my daughter spends on it, it makes me think that this must be a $12 billion business. So I had an experience 2 years ago that kind of reprogrammed me a little bit to thinking about the cloud, because I came at it from a computer architecture background, from a computer systems background. That's my research background, that's my engineering background. Thinking about it very much in terms of cycles and disks and arrays and grids and so forth. Initially approaching it, thinking it as just another large supercomputer, the sort of things I would have logged into in my grad school days. But I had an experience 2 years ago at Target when my daughter wanted to buy an airplane, a Littlest Pet Shop airplane. Obviously, there's airplanes for little pets. And it cost $30. So I'm swear this is going to become a $12 billion business. So I asked her, well, $30, all right, so really, you know, but you have to spend that, do you have that much in your allowance? Yeah, Dad, I have $275 on my allowance. What, really? And then she whips out her iPhone, because we're a gadget-rich family, and she looks up the Google spreadsheet on which I have the formulas that calculate how much I owe her. It's updated automatically. And she shows to me, yeah, Dad, look, you owe me $275. So I take out my iPhone. I've since joined Google. I now would whip out my Android. And I have write privileges. So I update that trick sheet and deduct $30 from allowance. It's then updated on her phone, and she can happily go off and buy this airplane. And that, to me, when I realized, wow, this is cloud, right? Because cloud isn't defined by the bytes and the disks and the bandwidth and so forth. It's really that it's everything that's not on your desk or on your lap or in your hand or in your server room. You don't really know where it is, but you can reach it from your browser, and you can probably reach it from your phone. And the next generation isn't even going to think about that thing on the other side as a computer. The kids growing up today are going to think of it as that something other thing that I'm talking to, be it be it the GPS that's running in my car, be it their allowance application on their phone, be it the grades they're getting from their school. It's just running somewhere else. So that is the cloud. Again, looking back at how I approached thinking about the cloud initially, I just saw it as a progression of how you use technology. You know, your starting point is, and this could be seen as the life cycle of a startup. You start by running it in your garage, and you run everything yourself. Then you go somewhere and you rent the server somewhere, and you start basically outsourcing more and more of your stack. And at some point, you're going to the far right, which is a platform as a service, as it's called today, where you don't want to care about anything else. You just want to upload your code. And that's a design target for App Engine, is that you should have to know as little as possible about all these other things. But I would posit that this is just the beginning of the journey, right? Because the initial argument is that it's all about sharing the resources. We can be running lots of applications. And tying back to my earlier numbers, we're now running hundreds of thousands of applications from hundreds of thousands of different developers at the same time on the same infrastructure. So you get economies of scale and so forth. But there's a lot more to it. One is that we're running our services, our API services, enmeshed in this environment, right? So you don't have to bring up an email server on your stack and worry about it. You just hook into a service that provides it, and that service is running in more or less in the same environment managed by, in our case, Google. And that gives us economies of scale, right? Because our email server that you hook into is this little thing called Gmail. Right? So we use the same backends for Gmail as we do for App Engine. We have similar things for things relating to images, things relating to text processing, things are NoSQL solutions, the SQL solution that we just rolled out last year. These are all things built up to be sharing in this environment. And there's lots of, and this is more fundamental than just the computation. I would posit that this is a fundamental reorganization of human affairs. This picture here is a city diagram of the bazaar in Istanbul, which I think was built in the mid-15th century. So the notion of the marketplace or the bazaar is literally as old as society itself, or in terms of age of history and the age of our ability to build cities. In fact, one of the drivers for a city or a town was the ability to come there and trade. And you notice that we build a wall around it, right? And you notice that we standardize on communication. So these are streets connecting different services. And they'll get clustered. So you'll have the fish sellers in one area. You'll have the meat vendors in some other area. And you will have standardization on all sorts of interaction things. You'll have standardization of coinage, which was driven out of this environment because you want to facilitate trade. You will have standardization of identity management, show us your papers. Some of the very earliest usage of writing was these stamps that would identify that you as an individual, your sigil. That's nothing more than identity management, right? These things really, this invention of creating this environment so the city didn't own everything that was going on there, right? Because we know that the model where it was owned everything, the top-down, fully organized society, we would today call them communism. They've been tried and called different things over the millennia, but doing it fully top-down doesn't work. But creating the public place is effective, and that's what I would posit what the public cloud is going to become. You're going to start having you will have eventually a small number of public IT providers that will be providing more or less the bazaar and providing the communication parts, the standardizations within it. You will have the safety that when you've shown your papers to the soldier walking through one of those gates, you can be trustful that the owner of the bazaar has gotten rid of all the pickpockets as best as possible. Back in those days, they'd be hanging those from different corners just to underscore that they've been cleaning out some of the thieves. And it's all, what's the difference between a pickpocket and a bazaar 1,000 years ago and a denial of service attack against your firewall? I mean, it's basically the same parasitical behavior. So this goes way beyond just optimizing resource usage. Another example is gold, and this is a picture taken from the Federal Bank in New York, which I don't know if those of you saw the James Bond movie that was topicked on it, but it's based on a true situation. So in the early 1900s, by some estimates, 10% of the entire world's gold gold stock was in this one vault deep under Manhattan. Why? Because when you wanted to move gold between what was owned by different countries, it's really difficult to move them across seas and continents. So you would entrust this bank, who would just move the gold from one storage for one country to another storage to another country. This is data, guys. This is the same problem we're facing now with big data. Big data has mass. It's becoming more and more difficult to move it between services. So another huge driver for the public space and the public IT cloud is the weight. And literally, if you look at the physics of information theory, information has mass. You have to move it. And we will get that aspect as well. That will be converging to large applications. If you have a petabyte of data and you want to lend it out to somebody to do some processing on it and then charge for that, you can't be shipping that between servers. That has to be in the same data center. And of course, finally, the argument is sharing is good. And that's it. Thank you very much.